fluid transport, gas absorption, distillation. This is just a list of all the unit operations which you learn, correct? Similarly, you have unit processes, right? And these combining with a help of a specific piece of equipment, which is what we call it as a chemical reactor, allows you to practice these unit operations and unit processes in a most efficient way, in a sense that these conversions or these transformations do require certain amount of energy and certain amount of efforts. Any chemical, physical, biological operation is associated with some transport of energy, some transfer of energy. Either you need to remove the energy or you need to add the energy. If the reaction is exothermic, to maintain the conditions you need to remove the energy. If the reaction is endothermic, to continue the reaction you need to supply the energy. Right? So again, energy balance comes into picture. What are the basic problems which are faced by the country? Soil productivity, day by day, because of the indiscriminate use of fertilizers, the nitrogen to phosphorus balance is getting disturbed, as a result of which the fertility of the soil is reducing. So you are able to get only certain crops. Can we contribute as chemical engineers? Can I take a field as a reactor and see what are the energy inputs which are going, which is essentially solar energy, the inputs in terms of seeds, the input in terms of water, the inputs in terms of fertilizer, micronutrients, and can I do a complete material balance on my field and come out with a model which tells me that at the end of 3 months or at the end of 6 weeks or 8 weeks, this is the total growth of the plant which is going to take place, or total quantum of food grain which is likely to be made or expected, which we'll learn in due course of time. But in all of these cases, the fundamental starting point is you define the boundaries, and around that boundary you carry out material energy balance. So I've chosen some topics which I am going to talk about in today's lecture. Solid fuel burning stoves, I'll tell you why this is so important. Then once you have a stove, you've got to have certain cooking devices where either you can use solar energy or the energy which is released by the burning of biomass. Pyrolysis and burning of biomass can result into bio-oil and biochar, how it can be utilized. And I'm going to conclude my talk with this latest work where the ubiquitous hand pump, which you are aware, you just walk outside and you see this hand pump which is connected to a borewell water. What we have been able to do is we have been able to modify this particular hand pump in such a way that the water which is coming out at the spout comes out disinfected. So you don't need to take out the water separately and then disinfect it by using chemicals or boiling it out, so on and so forth. I'll tell you the basic principles how it can be done. These are the typical problems of the rural area, and I will list out the other challenges which are still being faced by us as chemical engineers, and how we as chemical engineers can contribute to these challenges. Why these topics are important? Let me give you some perspective. India has 16% of the world population. 16% of the world population, and has 7% of the land mass of the world. So obviously the population density is extremely high. Now the 16% of the population require at least 2 square meals a day, and you all know that Indian cooking practices are multi-step synthesis processes, and the moment the process becomes multi-step, the yields and the efficiencies go for a toss. So it is necessary for us to look at how much energy we are consuming just for cooking of food. And if I just do the back of the calculations, you will be surprised to know that India uses anywhere between 30 to 40% of the total national energy consumption only in cooking food. Now the same number in the developed world is less than 5%, as a result of which they do not have any incentive to work on these areas where the contribution, even if you develop, let's say come out with a 50% efficient cooking practice, you are addressing only 5% of this energy component, whereas in Indian context, you are addressing that 40% of, but who's going to publish that? If you do the work properly, scientifically, people are more than willing to publish these kind of things because it brings out a completely different aspect to this energy distribution. So about 40% of the energy is consumed in cooking, out of which only 14% is commercial fuel, such as kerosene, gas, LPG, or biogas, and balance 86% is still biomass. So 86% is non-conventional, and when I say it is wood, biomass, cow dung, and agricultural residue. These are the typical waste fuels, biomass fuels, which are used. If you are using any of these, wood, biomass, and cow dung, and you are working, carrying out cooking in a house extremely inefficiently, the calculations indicate that on an average, a single household spends anywhere between 16 to 20 hours per week to gather the biomass which is required for cooking purposes for a week. Right? 16 to 20 hours. Meaning nearly 2.5 days of productive work, because if you consider 8 hours as a working period, is being spent in just collecting the firewood or collecting the biomass which is necessary for cooking purposes. If I develop a device which efficiently burns this particular biomass, and let us say I am able to improve the efficiency to 50% from the existing level, then it is possible for me that on an average I will be saving 8 to 10 hours per week. Now 8 to 10 hours per week is equivalent to days daily wages, which is approximately 275 to 300 rupees per day, the government approved rates, and you can calculate the number is staggering 4 lakh crores of rupees in terms of availability of manpower to do work which is productive for the nation, not just spending time for collecting of the biomass which is necessary for the cooking of the food. So essentially the point which I am trying to convey, that even though the topic doesn't appear glamorous, the topic has a major impact on the economic scenario of the country. In addition to that, one needs to look at what are the current practices which are used. These are the typical old practices and improved designs of these particular stuff. And if you look at it and try to find out, is there any scientific literature which is existing in this, and you'll find that hardly any scientific literature exists. Nothing has been specifically analyzed, modeled, as a result of which whatever people say is more of a hearsay. Some reports are there somewhere which tells you this is the efficiency, that is the efficiency. Work has continued for the past 25 years, and currently there are about 52 different types of stoves. Right? MNRE recommends that these are the stoves which are to be used, and these stoves have got efficiencies which are pathetically poor. I'll explain it to you in a minute. These are the new ones. 3 stone for 8 to 12% of thermal efficiency. That means 8 to 12% of the calorific value of the fuel is effectively utilized for cooking purposes. You improve that, single and dual pot mud stoves, it improves to about 10 to 20%. Improved open fire built on the raised grade, 15 to 20%. Improved metal stoves, 20 to 25%. What does it tell you? Still 75% of the calorific value of the fuel which is actually can be harnessed is being wasted into the atmosphere, because we are burning that anyway. So you are contributing it to the global warming, to the greenhouse gas emission, without actually utilizing that particular energy for effective purposes. Now tell me, you take up any chemical industry, would any chemical industry work with the thermal efficiency values of about 15 to 20% on a sustainable basis? Never. You have seen the typical thermal efficiencies of any heat exchanger device exceed 80%, 85%. You take a boiler, the industrial boiler would have efficiencies in the range of 85 to 90%. That means 85 to 90% of the calorific value of the fuel is being utilized for the conversion to, say, steam or thermic fluid heating or any such devices. How can this be sustainable at 15-20% thermal efficiency? Not. In principle, if you analyze each of these stores, it is possible for us to improve these efficiencies at least to 50% without a significant effort. And I'll tell you how one can go about doing that. So low efficiency is consuming large quantity of solid fuel. Just because it is available doesn't mean we should use this consumption. Inefficient combustion also results into these kind of activities, and I'm sure you might have seen a report somewhere that a woman sitting in a kitchen and cooking a meal in a smoking chula for a day, and in a week's time her inhalation of the fumes and inhalation of the smoke is equivalent to smoking about 400 cigarettes in a week. So the ill effects of that and the subsequent medical treatment which is required, I am still not considering that. I said 4 lakh crores can be saved in terms of only the manpower availability. If I can eliminate the requirement of the medical treatment cost, this number is staggering 10 lakh crores. So you can imagine you can have best of both the worlds. You can have more efficient cooking practices by designing a stove and a cooker associated, and I'll be talking about both of these, and this then is likely to have a major impact in terms of health of the people as well as health of the economy of the country. Or pyrolysis of the wood, homogeneous combustion, that is the combustion in the gaseous phase of the volatiles which have come out, then the heterogeneous combustion, which is the combustion of the char which is remaining at the end of the operation. So these are the 4 steps which are occurring in our stove. These are all classical chemical engineering operations. It's a combustion operation, it's an oxidation operation. Can we write this? Right, we can write this, we can model this, and I'll tell you how it can be modeled, can be done. So the motivation is rural population is not having access to LPG. Rural population cannot afford fixed and variable costs associated with LPG gas stove. Availability of large biomass is making the wood stoves as a ready-made option for India. You'll find that in fact, because of the increase in the fossil fuel values, many of the industries have also gone for biomass derived boilers. Right? Briquettes are being used for burning in boilers rather than furnace oil or gas. Of course, that is going to be available provided sufficient quantity of briquettes are available. In your area, Uttarakhand area, there are companies which will collect the pine needles and then convert that pine needles into briquettes, and these briquettes are being sold as biomass fuel. I'll tell you what are the typical calorific values of these as well, and this works out to be much more economical as long as you combust them more efficiently. Right, so the objective is to design a solid fuel burning stove meeting the requirements of low emissions and high thermal efficiency. Right, you can read this